record. So let me quickly share my screen so that all of us can also. Can you see my screen now?
Yes, sir.
Can we see my screen, please?
Yes, sir.
Yes, sir.
Yes, sir.
You are all welcome. So if you look at inference statistics, there are certain things we need to observe from there. One of it is it's full of words, and we have a lot of calculation there. But that's why we'll just pick one of them. Let's look at the chi-squared, and before we go into chi-square tests, I hope you still have your table with you. Under your table, we can use your table also to do some analysis. But on the chi-square, how do we solve the chi-square problem? What are the things do I need to know on the chi-square level? Is it also hypothesis? Yes, we use hypothesis to solve them. I will just go straight to the example. But before the example, let me see whether I can show you something on your book. And from then we can proceed. We have a lot in your book, though some of them are scattered, but I can still show us. Then from then, so that we are repeating ourselves on the book. So this is hypothesis. This is the estimate part of F-test. We've done all those things. Okay, if you look at this chi-squared, we have what we call degree of freedom. Under the chi-squared, we have Z alpha over 2 degree of freedom. This is the tabulated one. Or this is the tabulated one. But let's look at the main calculated one. This is the calculated one, we call it chi-squared. It's the name of someone that discovered it. Yeah. On these, we have observed and expected. O stand for observe, E stand for expected. So we have observation, we have expectance, and from then we proceed. So we have all these analysis, which might not be too palatable to some of us. But by the time we solve example now, we will understand all these analysis better, and you will appreciate it. As a matter of fact, I don't want to pick any of example here, because after the example here, after the example, we will come back to this place. You will have a better idea. Let's just start. Let me just start beside here, so that I don't want to go up too much. Chi-squared. Chi-square test. Excuse me. So what do I need to, what formula do I need when I'm being given a chi-square table? How do I know it's the chi-square table? These are the steps we need to check. Let's write this question down. Number 1. Dr. Godwin wanted to investigate if gender and prefer color
Hello, sir. Are you writing it? We are not seeing it.
you are not seeing, or all everybody are not seeing? Can we all
We are
see?
seeing it. Yes,
I'm
we are
seeing
seeing
it.
it.
I'm seeing it.
It's your network.
seeing.
Oh, I'm writing. Oh.
If you reload his network.
Were independent. That is what this doctor wanted to, is trying to do, is to investigate that being a male, do you attract to a particular color, or being a female, do you attract to a particular color? So that is investigation this man is doing. So you want to know whether it's independent, whether blue is independent of red, or so let's try it. That said, this means that he wanted to find out if a person gender influences their color, choice. So he conducted a survey and organized his data in the following table. So look at the table. We have black, we have white, then they have male, they have female, they have red, they have blue. So for the black, we have 48, 34, 12, 46, 33, 42, 57, 26. So the first step is for us, so we want to test of independence, write the non-hypothesis, and for us to write the non-hypothesis of this, remember what's the intention. We want to see whether it depends or not. Step one, let's write now. We want to solve the solution now. Step one, write the non and alternative hypothesis. Write the non which is H naught, and alternative, which is HA, hypothesis. So how do we write the non-hypothesis in this case? The ones you know and the ones you don't know, and the one you want to test. So for us to write, which is the one you claim and the alternative is gender. I'm writing the claim now. Gender and prefer shirt color are independent. So that is how to state it. Then, if you now want to look at the alternative, will be the gender and prefer color, prefer shirt color, are not independent. Now, we are doing this thing. Yes, Dana, you raise up your hands.
Yes, sir. Good afternoon, sir.
Good afternoon.
Please, sir, I thought you said the alternative is TH.
Is what?
TH, as in the H that you put in brackets after
No.
the null.
And alternative is A subscript H.
Okay. Thank you, sir.
Okay. So now, some of you might be saying, you might be asking yourself, after all, it's going to be multiple choice. Correct. But what about when you are writing your dissertation, your project? You will use, majority of you in business, accounting, in banking, in any other field, in social sciences, you will surely need this when you are writing your project. So it is better you have idea. If anybody is assisting you, you will know that you are stating the right thing. So what you claim and the alternative of what you claim. Please take note of that. So the next step is to calculate. Let's now look for step 2 now. Is calculate the chi-square calculated. Chi-square calculated. How do we calculate chi-square calculated? You go back to the table. We draw the table again. The formula to calculate the chi-square calculated are very simple formula. Under that formula, we have what we call the chi-square formula that we all know. Talking about the let me give us this is the only step that we have chi-squared. We are still coming to this calculated. Calculated will be the summation of observation minus expected all squared divided by expected, which is the same thing as chi-squared equals to over E. The summation of everything, the entire thing, is what we. Then how do we get to all this? Let's go to the table. The table will lead us there. So please manage these steps carefully so that you use the same step to check what they've done in your book and to also do it to practice. If any question come on it, if they ask you, how do you get observation? You know. How do you get the expected? You will know. So let's draw the table. We have two tables to form now. The first one is we have male, we have female. Then we have total. Remember the first one I stated up is nothing like that. We have black, white, red, and blue. Red and blue. So let's put so we have total here. We know that we have here 48, 34. We still have another total here. Then we have 12, 46, 57, 26, 57. What is our blue? So the red is what? 33, sorry. 42. Okay. So we have this. So what you need to do is let's bring out our calculator, please. Everybody. Can we add? Now, when they are saying we need what we call row and column. When they said column is this. 1, column 1, column 2, column 3, column 4. Don't forget. But this is the row. Row 1, R1, then row 2. And this is what we call row 2. Please take note of that. So if I ask you to add row 1, what is the total for row 1? Everybody. That is, row 1 will be 48 plus 12 plus 33 plus 57. That is row 1. What is the total?
150.
150.
Yes, sir.
Do we all agree? Okay.
Yes, sir.
Row 2 now.
Yes.
34 plus 46 plus 42 plus 26.
148.
148. Thank you. Now, let's now do the column 1. Column 1, 48 plus 34.
82.
82. Okay. Column 2.
58.
58.
Column 3.
75.
Column 4.
83.
59.
Is what?
33 plus
Which one?
42.
75.
Yeah, we are. Oh, yes, thank you, sir. So now, can you add all the column together? This one, 82 plus this, plus this, plus this. What is the answer? This is what we call column total.
Both of them are 298.
98.
298.
The column-
Now, wait, let me just explain to you. We have what we call column total. This is C total. Then here we call row total. So when you add everything, this is CT, C column total. So when you add this one, you have two what?
298.
That means
298.
you must have 298 for both. When you add everything here together, column C, and when you add this together, you must have this.
Yes, the same thing.
If you don't have the same thing, it simply means there is error.
Error.
We call this one that I circled grand total. That is GT, grand total. So we cannot proceed by solving it one after the other. We need to make expected value from the table. How do we get our expected value from the table? Expected value will now be total of each of the following. It will be RT multiplied by CT divided by grand T. That is RT multiplied by CT divided by GT of each of the column we have, the table we have. Let's look at the table now. It's going to be I will use table to explain it so that you will have better idea when you are solving it by yourself. You can do it the way you like, but let me use table to explain. I will give you black now. For the black, I have, what is the value
40.
of, what is the total for black?
82.
82.
So I'm
82.
going to write 82 multiplied by, what is column, what is row total? For May, remember we are working on May.
150.
Look at it. I'm working with the May now. I'm working with this one.
Yeah.
So it's going to be what?
150.
150
Divided by
divided by 296.
298.
298.
what is the answer, please?
But 1.275.
41 point, let's say 41.3. Let me just use one figure. 41.3. All true. Remember, I'm working with May. So
41.3.
41.3. So I can go to white on the same platform. If I'm going to white, remember I'm still on the May. So I'll be
58 times.
So it will now be what? Total is 58.
50.
No, don't worry. We are mixing it. Let's write it in a good way. Let me first of all quickly this one. 150, so that anybody that are watching it will understand. So it's going to be, it's still the same thing. Row total is what? 150 multiplied by column total.
That's 58 times 150 divided by 298.
Yes. What's the answer?
Excuse me, sir.
Yes, ma.
Please, sir, you said that we are dealing with males, right? And
Yes.
for black, we have 48.
No.
But I'm seeing
You have to remember column total. Look
yes.
at it. Look at the formula now. Row total
Row
multiplied by column total.
by
This is the
column.
column
Yes,
total
sir.
for each of them. Not their observation. We are not dealing with the observation. This is observation inside.
Oh, okay.
Are you following it now?
Yes, sir.
Any other question, please? Okay, let's continue. So what's the answer for this? Punch your calculator.
29.2.
29.2. Okay. Now let's solve for the
Red.
red.
75 times 150 divided by
150 multiplied by 75. Remember the formula. Divided by
298.
What's the answer?
7.8.
37.8. Thank you. Then blue. 150 multiplied by total of the blue is what? 83 divided by 298. What's the final?
41.8.
41.8. Okay. So that is for male. We will do the female now. For the female, we have
148.
total
Times
row total for them is 148
48 times
multiplied
82.
by 82, the same 82.
Divided by 298.
So what's the answer? Thank you. I want every one of us to be engaged, please.
40.7.
Next.
148. 148 times 58 divided by 298.
Yes, what's the answer?
28.8.
Yes, next.
Next will be 75 times 148 divided by 298.
37.25.
Don't worry, at 10.2. You don't need to approximate twice. So the last one.
148 times 83 divided by 298.
82, sir.
Which one is 82?
41.2.
41.2. Are we all together now? Any question? So we all know the way we can calculate our expected now. Now that we have expected, the next thing is to make sure we now apply the main calculated, the one I stated here. That is when you apply this one. Are you getting it? So, any question? How do we solve this one? The one I've calculated will be, we know
Roots.
what is expected. This is, don't forget what is inside. Let me give you this. All this value you see inside, we call it observation. The one you will be given observation. Please take note. You are the one to calculate the E, which is expected. Look at it. This is expected value now. The one that I'm ticking, they are expected value for each of them. So all I need to do is to state it using my formula. I have my formula already. The formula says the summation of observation minus expected square divided by E.
Grand total.
Are you getting it? So we can now pick for the first May. Let's start from
14.
the May. Will be, open your brackets. The first value for the first observation for May is what? Anybody?
48.
For me.
48 minus 40. Expect
E.
the first expectation 0.3 all squared
0.3.
divided by.
1.3.
Now you can even write this one this way. Look at it. You can do it this way. Let me use another value, another pen, so that you understand what I'm doing.
I'm not seeing you.
E11, E12, E13, and E14. Then E21, E22, E23, and E24. Are you getting what I'm doing?
I'm not seeing it.
Is your network?
Uh,
Yes.
I'm
So
not-
I can do the same thing to this one. I can say 011, 012, 013, 014. Then 021, 022, 023, 024. So now, if I'm solving it, you will know that I'm in 011. So now I need, for this one now, it simply means that what I did, the first one will be 0.011 minus E11 squared divided by E11. That is the meaning. Plus 0.12 minus E12 squared divided by E12 plus dot dot plus O24 minus E24 all squared divided by E24. That is what we need to add together. So once you can get this one done, then you are good to go. Let me just clean this place. Any question, please?
Hello, sir. We can't see. Good afternoon.
What is happening to your network? Who cannot see again?
I cannot see him too.
Can we all see now?
We cannot.
You cannot see.
We are seeing the screen, but it is not moving.
But me, I'm seeing everything.
It's not moving. It's not moving.
The last there is the chi-square
48
calculated.
48 minus 41.3.
Now it's
Square.
showing.
It's showing now.
Network. It's your network.
It's the network.
It's the network because me, I can
It's
see
the
very well.
network.
You can see, I can see. But now,
Can you see now?
it's okay now.
Try to leave the meeting and join again.
Where can I come back? Where can I? Okay. Can you see from here now? What can you see on my own?
Yes.
I now have seen the new colored pen.
Okay, let's start from here.
I think the network is better.
Is network okay now?
Nigeria.
Don't worry. We will get there one day. Okay, let's look at it. What I'm doing now is I'm just trying to label this one that I teach. They are called observation. That is the question you are given. You will be given observation value. Now, from observation, you will be the one to calculate expected.
Yes.
What is the formula to calculate expected value? They are this one. That is RT multiplied by CT divided by GT.
That will forgive expected.
Yes. Expected of each of the observation.
Then we take the observation one by one.
And can we proceed now?
Lisa, can you come again with the explanation?
Okay. Okay, step 2 now.
Move on.
Please listen. Everybody, please listen. Let that be.
Okay, sir.
Please don't talk. Just listen. Now, step 2 is to calculate our chi-square calculated. When you are doing chi-square calculated, the formula is observation minus expected square divided by expected. Please don't square the expected. Be careful.
Yes.
Are you getting it now? Don't square the one denominator here. Leave it the way it is. Now, we all know the way we have this one from onset. So we have observation 011, observation 12, observation 13, observation 14.
I can't see anything.
You said?
I can't see anything.
I will advise you to off your video. Don't use your video, please.
My video is not on.
Or look for a place where you can sit. Change your location where you are.
Okay.
Yes, change your location where you are sitting. So far, it's not general. It simply means it's from your location. Look for another location. Is it raining?
No.
No, sir.
Okay. Just change your location. When you change your location, you will, to get a better network. Where you can see, that is the best place to stay. So from there, we calculate our expected value. RT multiplied by CT divided by GT. So from there, we can get this. So we will be picking, we will take them one after the other and add everything together, and that's settled our case. So how do we do that?
Yes.
Can we please mute ourselves? Thank you. If you cannot see, please be listening. But if you can see, still be listening and write. So after the video, I will also upload the video immediately. So now for the expected value for this one now, to calculate our chi-squared, what we need to do is, what is the first observation? 011. 011 is what? From your table.
48.
48. minus E11
41.3.
41.3.
squared divided by 41.3 plus 012
So
58.
012 is what?
12.
12. Thank you. Minus E12
29.2.
29.2.
9.2.
divided by
29.2.
so 013
33.
33 minus what?
37.8.
Minus 3.8 divided by 3.
Minus what?
37.8.
37.8 divided by 37.8 plus,
57.
okay, let me just manage this. 57, right?
Yes, sir.
Yes, sir.
Okay. 57 minus
41.8.
41.8 all squared divided by
41.8
41.8. So plus
plus
021
34 minus 40.7
plus
40.7
40 what?
then 46
E
minus
26.8.
28.8
divided by 28.8.
38.8
plus the next one
42
minus
minus
37.2.
the last one
37.2.
26
minus
41.2.
So now we need the value for each of them. At this point, you have to be careful, but we are going to do it one after the other so that for chi-squared calculated will be, now let's 48 minus 41.3, what is the answer? Forty-eight minus 40. Please, let's bring out our calculator. Just pick one.
6.7.
1.09.
1.09.
6.7.
No, it can't be 1.7. Check it.
1.09.
6.7.
No, 48 minus 41.3 all squared.
Squared. Divided
Now
by
divide it with 41.3. What do you get?
1.08.
1.08 what?
86.
Okay, let's make it 4 digits after.
Okay.
86 what? Do you have the same thing?
Yes.
Okay. Now let's do the next one.
If we approximate it to give it 7.
And we are making it 4 digits after the decimal place. Are you okay with that?
Yes, sir.
The second one is 10.1315.
So everybody, please do it. The third one, anybody? Somebody should give us the third one. Okay, let me call your name so that probably I will assign it for you. Okonko. Next one is for Okonko. Next, number 5 is for Kelechi, Professor Kelechi. You have to put Professor there. Who again is on the line?
The first one, are we together with that 1.0867?
Yes.
I don't think we're together.
Okay. What is your calculator saying?
I don't know how many places of decimal you want us to put it.
4. 0, 6.
So the 9 will convert to 7. 1087.
Please, my own calculation is telling me 10.27222 for the first one.
No, okay, let's do it this way. I will just show you the way you would do it. Can you see my calculator? Can you see it?
Yes,
Hello?
sir. Yes, sir.
Okay, let's do it. 48
Yes, sir.
minus 41.3.
Okay.
Squared divided by 41.3. Can you see it now?
Yes, yes, sir.
1.087.
Very good. That's why
All right, sir. Thank you, sir.
Are you getting it now?
Yes, sir.
that's what I have.
Sir, please, could you?
You said what? Somebody's asking. You said?
Yeah. I said, could you solve the second one? Because mine is with.
Just follow the same step. You will get it.
Okay.
So the second one, okay, the first one we have instead of 7, 9, right? Is that what Kelechi was saying?
Yes, sir.
Okay, good. Now the second one, just follow the same way I just did the first one now. How many of us have did you get the same? Because majority of you guys, this is where the problem normally lies.
So the first one is 1.087.
1.0869.
No, 9 can take the 6 to
Don't
7.
I said make it 4 decimal places.
Okay, thank you.
That is why I leave it that way.
Okay, sir.
The second one, you said 12 minus 29.2. Remember, you have the square already. When you square it, this is what, right? Then divided by 29.2. Can you see the answer?
Yes.
10.1315, and that is what the person that gave us.
10
Some
point.
my own has negative.
Yes, it's because you are not doing the square root very well. You cannot do the square very well. You have to square it. You will have negative, but when you square the negative, it multiply by 2. It multiply negative multiplied by negative will give you positive. Please take note. So let's continue. The third one, please.
0.6095.
I can't hear you.
0.6095.
Do we all agree?
Yes.
Yes, sir. It's correct.
0 points.
0.6095.
95.
Okay, next.
6.0592.
5.5272.
5.5272.
72.
Do we agree?
Yes, sir.
73.
Next.
1.1029.
1.1029. Do we agree? Just go and confirm it by yourself. The next one.
10.2722.
Next.
0.6193.
0.6193. Next.
5.6077.
77 or 78.
Okay, approximately 78.
Okay, now let's add everything together. What do we have? I'm waiting for us. So what do we have? What do we have, please? So we move to, while we are waiting for the final answer for this, the step 3 aspect of it.
The answer is 34.9571.
9571.
72.
71 will get you. Maybe because of that approximation.
Yes, no problem. Now, 34.9571. Good. So we have calculated one. Now let's look at the tabulated one on our table. I believe you still have your table with you.
Yes, sir.
Yes, sir.
So in this case now, we'll be checking. Let's calculate degree of freedom. Calculate degree of freedom. So for degree of freedom, we call it DF. It's the same thing as number of row minus 1 multiplied by number of column minus 1. So from the original question, let's go back to it. How many rows do we have in this case? And how many columns? Remember, I told you this is the column and this is the row. How many rows do we have?
I have 4 rows.
Really?
2 rows, 4.
Okay, 2 rows and 4
Well, it's not
columns.
showing again. Oh, God.
Sorry. How many rows do we have now?
2 rows
Can you
and
see
4
it now?
columns.
Okay.
No.
How many rows do you see now? 2 rows. They are there in your notes. You have row of male and row of female. And you have column of black, column of white, column of red, and column of blue. How many?
4.
Yes.
1, 2,
So
3,
it
4.
simply means our degree of freedom will be
1 times
2
3.
minus 1 multiplied by
4 minus 1.
4 minus 1. So which means our degree of freedom is equals to 1 multiplied by 3, which is equals to 3. So we have degree of freedom to be 3. Now, at alpha, if your alpha is equals to 1%, what do you have? Just a minute. So what we are saying is at alpha equals to 1, what happened?
Our answer is 11.345.
You will tell us where you get your own. Anyway, it's fine, but let's look at it together. So what we are saying is alpha chi-square, this is chi-square tabulated now. It simply means 1 divided by 100 is what? 1 divided by 100 is what, please?
99.
Is 0.1.
0.1. Yes.
0.01 is not showing.
Just be listening. Don't be disturbed, please. Just be listening, please. We are just doing alpha equals to 1%. And like I told you, Kelechi, if possible, you can change the direction where you are sitting. Just move to where you
0.01.
So now in this place, our chi squared, this is the way to go, chi alpha, comma, degree of freedom. We will now say chi squared is equals to 0.01. You can add 0, comma 3. We know the comma 3 is degree of freedom, right?
Yeah.
I think I gave you a table sometimes ago.
I don't know
Yes,
it.
sir.
Do we still have it?
I have mine.
Can you see
No,
my
no.
table now?
Yes, sir.
Look at this, the table that I gave you sometimes ago, page 9 of the table. That is where they mention chi-square significant level of significance level. We are dealing with 1 now, 1.01%. On that degree of freedom of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But degree of freedom is what? 3.
3. Under 1%.
Under 1%, what do you have?
11.345.
11.3.
That is how you check it.
We don't see it.
You said?
Not the table.
Yeah, the table. That's how you check the table. So if you don't have it, I think anybody that still have the copy, the one I share with you, can also reshare it on the platform. So 11.345. But what happened when our alpha is equals to 5%? Yes, gift.
Yes, sir. Why are we converting the 1%?
You are not converting. We are just trying to write it the way it's supposed to. Whether you convert or not, it's still the same thing. Some table will put it in this way. Some will leave it in 1%. The one I show you now, he put it in 1%. That is why you can say, why do we need to convert? Some will just put 0.01. So if you don't convert from 1%, if you don't remove the percentage, you might not easily get it. So that is why what I'm doing. Is it okay by you now?
Yes, sir.
So the one of 5%, can we do the 5%? Under 3. What do we have?
7.815.
0.05.
Yeah, 0.05. I agree with you. But when you check your table, what do you have?
7.815.
Yes, thank you. 7.815. So it simply means chi-squared tabulated 0.05, 3 equals to 7 what? 0.815. That's all. So from here, we can now check our critical, whether we are to agree or to reject. Your exam can be funny. They can they can do all the calculation for you. They want you to make the decision at this point. And they just say, critical value of this is equals to this. What happened? Do we reject or we accept? And in this case, we have our chi-square calculated to be equals to 34.9571, and chi-squared tabulated is equals 11.345, and or we can still have it to be 7.815. Any of the two, they can use any of the two. But at what point do we need? At any time, you don't need to reject the H0 when, if it is greater than, if it's greater, critical value is greater, but in this case it's less. So we have it to be 34. You can put it this way. Chi-squared calculated is greater than chi-squared tabulated. Do you agree?
Yes, sir.
Because our,
yes, sir.
our calculated is this, our tabulated, they are here. So it's greater than them far. So at this point, we can reject H0. That is, yes, gift.
So the calculated is the critical value.
No.
Tabulated is a critical value.
Calculated, listen, no. Calculated is the one we are doing. Critical value is the what you are checking here. Look at it. Look at the way they put it on the table. Can you see it? Hello, gift.
No, sir. No, sir.
You can't see
I'm
my
seeing
table.
it. I'm seeing it now.
Yes. critical value of chi-square. They are the one here. That is why we call the other one calculated. We did that calculation by ourselves.
Yes, I'm seeing it's okay.
So calculated is the one you did by yourself. Tabulated, which is critical value, they are the one that is already in the table. Any question? So we reject.
Hello, sir.
Yes.
This thing we are doing, can the exam we do the calculation up to this thing?
I will explain the way they normally do. They can give you a table.
Because
listen, no, they can give you a table.
Yeah.
They can make 4 or 5 questions out of it. Are you getting it?
You can give all the example of the table.
They will give you the table. If you check the past question, there is there. If they will not send part of it, they will not give you. And that is why I first of all mentioned something. I said, don't say because of the exam you want to know this. Know it because you will need it in future. You are doing degree, not HND. You are doing degree, not ND or not NCE. At the decision table, these are the things you'll be using to make decisions at your workplace and some other places you find yourself. Data is life. So if you don't know how to analyze your data this way, you might have yourself to be blamed. For those of us that are doing professional exams, you agree with me that they will still bring this one when they are doing statistics.
Yes.
So it is better, you have a better understanding now than when you get to professional field where nobody will teach you. It's still the same thing. So you reject H0. Therefore, the gender, it simply means, if you look at it, let's go to our H0. Look at it. The H0 said gender and preferred shirt color are independent. So if I reject H0 now, I reject this H0. What does it mean? I will accept alternative. Sorry, those of you that are having issue with your network today, bear with us.
Accept the alternative.
Yeah, you now accept the alternative that gender and preferred shirt color are not independent. Yes, Yaya?
Yes, I want to ask, can we put another language that gender and preferred shirt color are dependent instead of are not independent?
You can put it there.
Okay.
It's possible. Because opposite of independent, when they say are not independent, they are using negative to negate the statement. So it simply means gender and preferred shirt color are dependent. Simple.
Okay. Okay.
Yes.
Hello,
Thank
sir.
you so much
Hello,
for that
sir.
observation.
If the calculated is less than the table one, how can
you now accept the H0?
It's a H1. Yes.
You will accept the H0, the non-hypothesis.
And then
you now conclude that
the
gender and preferred shirt color are independent. I hope I'm clear.
Thank you, sir. Yes, sir.
So that is the way, is opposite way. Any question on that? Let me, yes, Gift.
Yes, sir. So I'm saying now, since that this 34.951 is the answer to step 1.
Is the answer to what?
It's refer to step 1 that gender and color they are independent.
No. 34.971, they are the calculated one. Let me go to your book. Let me go to your book. Look at these examples they did here. Look at the way they put it too. Let's go to this book. I know majority of you don't like it, but it's still good. Let's just explain something. Don't condemn me totally. Now we have this same formula that we make simple is the same thing. It's the same formula we are talking about.
It's
the
same thing.
Are you seeing it? It will make more sense now to you when you have better idea. You can see.
You can work it through.
You can work it out. You see, they use Chi 1, 2, Chi 1, 3, Chi 1, 4, Chi 2, 1, Chi 2, 2, Chi 2, 3, Chi 2, 4. It's still the same thing. Are you following it? Now, at the end of the day, where they're making error, you can easily discover by yourself. What you can see, what do they call this one now? Can you see? Hello?
Yes, we can see.
The one that I circle is what?
Chi-square calculated.
Chi-square calculated. That is the one I circled. So I circled the chi-square calculated because that is what we've been solving. Now, look at this next one, critical value, the one they check in the table. Row -1 and column -1. So at the end of the day, in their own, chi-square calculated value is greater than, look at the same statement I just issued now. Look at it. Their chi-square calculated value is greater than the chi-square tabulated, which is critical value. We shall reject the non-hypothesis and accept the alternative. I hope I'm clear.
Yes, sir.
So it's still the same thing. That is the beauty of mathematics or statistics anywhere in the world. The same thing we are using in Nigeria is the same thing they are using in the US, in Germany, in Canada. If you have a friend that said he traveled out or he japa and he not get there, he said they are doing chi-square. Say you know it. It's the same thing. The same material we are using to teach you. Their own chi-square is not different because they are in Obodo. No, it's the same thing.
No.
Sir,
So,
please, what's the page? I can't see it though.
You don't need to see this one. It's in your notes. You have the book now.
The page number.
I don't need go to chi-square. Me, I don't understand your own page.
I'm not.
Okay, guys. All you need to do is
for unit 3.
Go to chi-square and you will see it. Is that okay now?
Very okay, sir.
So I believe chi-square problem has been resolved.
Hello, sir.
Yes,
go ahead.
Busted.
Say, please, could you repeat the conclusion again?
Okay. That's very important. Let me share the screen.
Oh, Lord.
Can you see the screen now?
No.
Yes,
So
sir.
cool.
Can you see it? Can you see the conclusion, please?
Yes, sir. We can see
Yes,
it.
sir.
The lady that asked us to read. So
But you made your own conclusion. It said when the calculated is more.
Okay, wait. Let me do it this way. Let me explain this way so that you will understand better. It's just a simple thing. Now, look at it. When calculated, let me write it down here. Note that please mute yourself once you know you are not talking. So note that whenever your chi-square calculated is greater than chi-square tabulated, is the same, is equal to, you reject H naught. Are you getting it? Let me just write it together. Reject H naught. Reject H naught, which is non-hypothesis. And accept
Alternative.
HA, which is alternative hypothesis. So, but when your chi-squared calculated is less than chi-square tabulated, accept H naught.
No, your H naught and reject
alternative. Are you getting it now? The lady that asked for the analysis, are you there?
Please, sir, you said whenever your chi-square calculated is greater than your H naught, we should reject what? What are we rejecting?
Please read the, can you see the screen?
Not so clearly, sir.
Don't worry, when you get the video, you will get it very well. Chi-square calculated, when it's greater than chi-square tabulated, which is the one, chi-square tabulated means the critical value, the one you check from your table, or the one they've already checked for you. The question can come in this form in your exam that, when do we reject? They can give you the symbol like this, or this symbol. They can give you that at what point should we accept chi-square calculated, or at what point can we accept H naught, and at what point can we reject H naught? So you need to learn this conclusion very well. It's important. That is, you can reject H naught whenever chi-square calculated is greater than chi-square tabulated. Then you can accept the H naught whenever chi-square calculated is less
than the table.
Than the chi-square tabulated. That's all. Okay. Any question? Silence means no question. And I want to advise you to go back to your notes, to your textbook. And from that textbook, you will see the example there. Take this method that we use to solve it, to solve the example there. You will know it's very simple. Now, let me quickly discuss estimation with us. We've done it before. Am I right? Are we there, please?
Yes, sir.
Somebody is typing. Okay. So let's look at the part of the estimation. What do we mean out of estimation? At what point then do we check the confidence interval? Estimator, what are the characteristics of good estimator? Estimation now. We use, when you are talking about estimation or type of inference, we have estimation and we have hypothesis testing. Estimating or predicting the value is what are we doing at that point? Let's look at a good estimator. Good estimator. One of the good estimator is number one. Who can tell us? How do we know a good estimator? Anybody? I hope you guys are ready for the exam. Unbiased. 2, is consistent. The 3, is relatively efficient. When they said unbiased, what do we mean by unbiased? Let's look at it. Unbiased estimator they are part of estimate type of estimate. They are types. They are part of they are type of estimates. Let's say types of estimates. We have what we call point estimate. With a single value. And then we have interval estimate. That is, this one is range of values. So when we have the range of values, a confidence interval is an interval estimate. Don't forget. With a specific level of confidence. With a specific level of confidence, e.g., when you say confidence interval, confidence interval is an internal interval estimate, the way I said it the other time. So, e.g., we have it 90% confidence interval, 95% confidence interval, 99% confidence interval, and so on. Then For the point estimates, they are part of the population. They said point estimator of population mean. You remember when you have a population mean, sample mean, for the point estimator of population mean, they are part a, they said is a point estimate a point estimate of population mean, that is mu. Remember what is that? Population mean. They are mu is the sample, is the sample mean. Is the sample mean. That is X bar equals to summation of Xi over N. They are the sample mean. But don't forget, we have also, for the confidence interval, the way I explained the last time, I don't know whether you still recall. For the confidence interval, we have, there's a 95% confidence interval for a population mean from large enough sample. So what is the formula to do that? X bar plus or minus Z alpha over 2 multiplied by standard error. When your N is greater than 30. When your N is greater than 30. But for the 95% confidence interval, what does it mean? But let me write this one. X bar plus or minus Z alpha over 2 multiplied by sigma over N, square root of N. At this point, my N is less than 30. Please take note of the difference between the two. So, but the examiner can give you the value for this by saying, if you check your table, it's there. It's not new. X bar plus or minus 1.96. How do we get 1.96? The way we get 1.96 is this. Z alpha in this case, alpha over 2, is the same thing as 1 minus 95%. What is it? Anybody? What is the answer? Anybody, please?
It's 5%.
0. What?
5.
0.5, right?
0.05.
0.05, right?
Yes.
So if you now said alpha is 0.05, so it simply means Z is alpha 0.05 divided by 2. What do we have? Somebody should help us.
0.025.
0.0. How many zero now?
0.025.
Thank you. So how do we now get 1.96? If you check your table, I'm not sure whether I think I uploaded the one that contained negative. They are symmetry. Anyway, let's go to the alpha. I don't know whether we have normal distribution. Okay. So if you go to, do I have the one that have negative? Hello? Did I upload the one with negative for you?
No, sir.
Okay, now I have one here. Probably after this, I will send it to you. Now, how do we check? From here, from this one, we want to look for this value on our statistical table. I will show you. I will send it to you. Check it. That is, you don't need to. I'm just giving you the method, not because of your exam. I'm giving you because of where you are going. So let's check 0.05 inside our table. Where do we get it here? Among all these values, 0.025. That is what we are looking for. So look at this. Can you see it? Hello?
It's blurred.
Yes, sir. We can see.
Yes. This is 0.025. Under what? 1.9.
1.9.
1.9 what?
Minus 1.9.
No, it's minus, but don't forget it's symmetry. Symmetry means whether positive or negative, we are still taking it. We believe what you are saying in negative will be the same thing you see in positive. So under 1.96, because you see it now, 1.9 under 6.
Oh, under 1.96.
Yes, that is where they got the value. So that is why we normally give you this 1.96. I just show you on the table. Now, that is not where we are going. I'm just giving you the formula. So the formula is just for 95% confidence interval. It simply means X bar plus or minus 1.96 multiplied by standard error. Then, if it is greater than, don't forget to, if it is greater than 30, if your n is greater than 30, that is when. But if n is less than 30, you have X bar plus or minus 1.96 multiplied by standard deviation divided by square root of n. This is n less than 30, and this is n greater than 30. So that is just the analysis. But let's look at the example. From example, you have agreed with me with what I've been trying to explain to you. That's okay. If you are given a particular, I'll just extract the value from this place. Let's look at the example 1. Says, suppose a researcher, or don't let me use a researcher. We have so many, suppose a professor interested in obtaining an estimate of the average level of some enzyme in a certain human population. Takes a sample of 10 individuals. Determine the level of the enzyme in each and compute
Hello? Yeah, alaikum salam. Good evening.
a sample.
I know. Have you arrived? Wow, that is good, bro. Very fast. Yes, I'm still in class.
Determine a sample and compute a sample determine a sample mean of X bar equals to 22. Determine a sample X bar equals to 22. That said, suppose further it is known that the interest that the variable of interest is approximately normally distributed with a variance of 45. We wish to estimate enzyme. We wish to estimate the, let's say, the M or the M sign that we want to calculate. So for us to solve this problem, number one, who can tell us what is the sample size do we have? Hello?
10, sir. 10, sir.
Okay, we all have the note, the solution now. Our N is equals to 10. Okay.
Yeah.
What is our X bar?
22.
Thank you. Then what is we are given a variance, which is sigma squared, you remember, is equals to what?
45.
45.
Then how do we get the standard deviation? By taking the square root of 45. We give you standard deviation. Now, our n is less than 30. Please, when they are talking about estimation, what do you need to know? It's just two formulas. It's just x bar plus or minus. Don't forget, we are still working on 95% confidence interval. It's still 95% confidence interval we are talking about. So will be 1.96 multiplied by sigma over square root of n. I know everything here. All I need is just to put it together. 22 plus or minus 1.96 into square root of 45 divided by square root of 10. So at the end of the day, what do you get, please? 22 plus or minus. So can somebody say, find the square root of 45 and find the square root of 10? Multiply it, divide it together.
Right.
Then use it to multiply 1.96. Who is doing it, please? Okay, look at it. The final answer is what? Anybody?
$6.7.
Anybody? This one can.
2.158. 4.158.
4.158. Thank you. Correct. So all you need to do is to split your answer into two. 22 minus 4.158, comma, then 22 plus 4.158. So at the end of the day, what do you have? You will have
26 points or 18 points.
17 points. 842, right?
Yes.
And 26.158 at 95% confidence interval. So that is what they ask you to calculate.
4.279.
That is what they ask you to calculate. Any question on this? So the same thing goes to when your n is greater than 30. And they give you all the necessary value. Okay, can we quickly solve this one on your own? I will just give you extracts. I will not give you the detail of our x bar in this number 2 is $250,000. Our sigma is $15,000. Then your N is equals to 64. So what is your value? Because they can give you this like this in your exam and ask you to solve. So all you need to use, the solution will be X bar plus or minus 1.96 that are 95%, then error. So solve it. Let's see who will get it, the estimate. If you have your estimate, let's hear you. Who is there? Anybody? So what's the final estimate for this? This is what is happening. Are we there?
Yes, sir.
So what is happening?
Not yet, sir.
Not yet. Okay. Oh. I'm waiting. No.
So it's 250,003.
No, which one now? Are you giving me the negative one? The one you deduct?
249.996.3. That's 249,996.325.
No. Which one are you saying?
The minus is 249,969.
249,996 plus 0.325.
0.99.
Wait, okay, you said 249.
996.325.
969.99.
Point.
325.
How many of us got this one?
No, not that. 249,996.325.
Okay, I think we need to do it together. You don't get, probably you don't understand what I asked you to do. Our X bar is 250,000 plus or minus 1.96 multiplied by 15,000 divided by square root of 64. Is that what we did?
Square root of 15,000 and
no.
80.
Square root of 64.
square root of 64 is what they ask you to, because you are already, that is why I gave you this question, so that you know the difference between when you are given a variance and when you are given a standard deviation. They give you, you are given standard deviation direct, you don't need to square it. But immediately the question is mentioned that variance, you know you need to find the square root.
You said it's variance. That's why we did the square root. I didn't know that value of 15,000 was standard deviation.
It's not. Okay.
It's 3.675.
Wait. Now, where you find the square root, the square root of 64 is what?
8.
8.
Okay. That means 15,000 divided by 8.
15 will be 15,000 altogether times 2.
Divided by
3675.
Multiply by 1.96.
3675.
Right? 3675. So you are to say 250,000 minus 3675, comma 250,000 plus 3675. So you can see the answer is what now?
The same thing I told you before, sir.
No, it's 246.
246, 325.
246, 325.
And
325.
The second one.
253, 675.
Thank you. 253, 675. Please, let's be careful. This is the estimate in dollar. Don't forget.
In dollars.
In dollars, so you have this one, estimates. So that is how to calculate this. But in case you are given binomial population, I think something like that. Yes, Naomi.
Sir, please, I can't see the screen.
Network.
I'm seeing it now.
Can you see it now?
Yes, I can see it now. Thank you.
It's network. It is well with us.
Nigeria.
Roots.
Sir, sorry to bring you back, but please, how did we get the 3,675 we've been using to calculate?
Yeah, it's here. 15,000
zero.
divided by square root of 64.
8.
Multiply by 1.96.
Square root of 64 is 8.
Yes.
Okay, so we divide it by
15,000.
15,000.
Yeah.
Divided by 8 times 1.96.
Oh, times 1.96. All right, let me check my own.
So, but what about when we have a binomial? A binomial population. As a point estimator. That is we are talking about proportion now. You remember when you are given points, estimator of population proportion. Proportion P. So at this point, we have our P cap to be equals to X divided by N. So what is our margin? Margin of error in this case will be P cap plus or minus 1.96, the square root of P cap, Q cap, divided by N. So in this case now, for the assumption, we have, our assumption would be NP when it's greater than 5. Remember the first one we said when N greater than 30 or less than 30, what do we have? But in this case, NP greater than 5 and NQ also greater than 5. So in this case, we like to check them. It simply means is 0 less P plus or minus square root of PQ over N less than 1. So, but the major thing, the major error that we're checking is this one. The major is P cap plus or minus 1.96 square root of P cap, Q cap over N. Remember, everything is based on 95 confidence interval, 95% confidence interval. That is just it. So we are just checking that, okay, at 95% confidence interval, what will happen if you have something like this? Am I communicating now? So for the proportion, let me just give us an example before we call it a day on the issue of proportion. How do we solve the one of proportion? Equality control, equality control. Yes.
Okay, thank you.
Can you equality control technician wants to estimate? Can you hear me now?
Yes, sir.
The proportion of soda can that are underfilled is randomly sample 200 cans of soda and find then underfilled and find 10 underfilled can. So in solving this problem, solution, what is our N in this case?
200.
200, thank you. What is our X?
10.
Our X is 10. Why is it 10? Now, let me explain.
Yeah. Okay.
You know, it's your discovery at the end of your sampling. Are you getting it now? What did you discover at the end of sampling? Then you will now back it up with the estimate. Let's continue. So for us to know our P, remember that from the probability, you have P plus Q equals to 1. That is, the total probability is what? Is what we call the sources of probability is 1. Then the failure means this is the sources. For the failure will be Q equals to 1 minus P, which is failure. Are you getting it? Then for the P, we need to calculate the P. Let's get our P. Our P cap is the same thing as S over N. I gave you in the formula. What is X? 10 over 200, which is what? 1 over 20. 0.05, right?
Yes.
Then our Q, we can calculate the Q now. 1 minus 0.05, which is 0.95. Don't forget. So I can now go ahead and say NP, I want to test whether it's greater than 5 or less than 5. NP will be what? 200 multiplied by 0.05. What do I get? What's the answer, please? 200 multiplied by 0.05.
10.
10, thank you. Which is greater than 5, right? Then NQ cap is the same thing, 200 multiplied by 0.95. What's the answer, please?
One nine.
190.
190, which is also greater than 5. Therefore, we can go ahead and use this formula, plus or minus 1.96 square root of P cap, Q cap over N. So what is our P cap? We know it. 0.05 plus or minus 1.96 square root of what? 0.05 times 0.95 divided by 200. So let's do it together. If you do everything here, what do you have? 0.05 plus or minus what? Anybody? 0.0 what?
.0002375.
Okay. So you have 0.03. Just leave it that way, right? 0.03.
Yes, sir.
So all you need to do is 0.05 minus 0.03. 0.05 plus 0.03. That's all. Add it together. What do you get? This is the point of estimate. At 95 degrees. So all you need to know is just how to manage your formula here. Once you remember that at 9 I can give you a small table that you might not even need to, but you need to check your table very well. In case you are given the table in the exam, they can give you alpha. If your alpha is, I'm just trying to digress. I've finished the solution for this. If your alpha is 0.1, 1 minus alpha is 0.90. So if your alpha is 0.05, this one will be 0.95. If your alpha is 0.01, it's 0.99. What's the Z table? Z tabulated. This one will be 1.645. This one will be 1.960. This is what we've been using. And the last one will be 2.575. So this value does not change from here to Germany. From anywhere in the world, it's the same. It's already established, it's established results. And that is what we've been using. So if you try it with other example, all you need to do, know when they are talking about proportion. Remember, when they are talking about proportion here, and when we are talking about point estimate, the one we did now. So there are two ways of testing your estimate. Estimation theory is not more than that. So how do they ask us in exam? For those of us that have the past question, you have it in your, I think I have one or two here. I'm not too sure. Let me check. I'm not sure. Okay, there's one here. They will be talking about different things. This is still talking about sampling. I think they've how many of us know about these? I think 2022, some people have done Start 206 in 2022. Am I right?
Yes,
sir.
Do you have the past question? Look for those past questions, 2022, 2021. Look for the recent one. It will help you to have idea. So look at this question now. Look at the way they stated this question. Because some of you that believe that they won't give you long question, is there. They will give you. Now, look at this one now. Estimation is possible only in the case of a what? Look at it. Estimate and estimator are, I just mentioned some of those things. This question is not complete. It's not good. You see, you can see jump to the one that is good. Look at it now. We did something like this. A student obtained a mean and standard deviation of 100 observation as 40 and 5.1. It was later found that one observation was wrongly copied as 50. The correct figure being 40. Find the correct mean and standard deviation. Don't say they will not give you. Look at this one now. The data given as this is called what? Unfortunately, we don't have a complete question in some of those things. But look at it. The weight used for Paget formula belong to what? Laspire index number possess what? So please, don't say they will not give you. Look at this one. The correlation is used to determine what? I mentioned it that day. Go and watch the video again. In regression, the standard error of the regression is what? The greater than the accurate of prediction will be given. Go and check your notes. Most of it will be the conclusion, but if you don't know the beginning of the problem, you may not know the conclusion. I'm not sure whether I don't have the question here. Some of the question, please. Okay, I think I have another one here. Have you seen this one? Can you see it? Hello?
No, sir, but we will
Yes, sir.
access the recorded version
see it.
later.
Okay. Look at the formula now. They are giving you the formula y equals to this. Given the array range, let's take our time. Okay, this is 2020 question. I think you have access to this one on your page. I'm not too sure. Or do you want me to share this one with you?
Yes,
Yes,
sir.
Yes, sir.
But the food is delicious.
Yes, sir.
No problem. I will do that.
Thank you.
Okay, guys.
Pastor, please, can I take us back a little?
Go ahead.
Back to the screen, where we have the square root of P cap and Q cap.
Yes.
Is the square root n inclusive?
Yes. Look at the way I put the formula here. The square root cover everything. So what you do in this case is multiply P and Q first, divide it with n. Now find the square root of the answer. Then the answer you get there, use it to multiply the 1.96.
Okay, sir. Thank you. Oh, God.
Any other question, please?
Hypothesis, all these things.
That is why I just mentioned it. I did not see your TME, but I know
They're asking of the variance, qualitative and descriptive, and the continuous all this thing, and then give us all this thing under our TME.
Let me explain things to you, all of you now. Go and start your revision from where we stopped in first semester. Everything that I taught you in first semester, go and read it. Link it with this one. That is how you read, though. Don't just read the second semester alone. You will not get some of those things.
Well, what?
Remember in first semester, we did variation coefficients. You will see variation of coefficients now. You will see all this probability that we did now. So start from your revision from that last part of everything that did not come out in first semester. Go and start reading it. Join it to second semester. You remember some topics did not come in your exam. So don't say you've escaped it or you did not. They are waiting for you. You will just see the question, you'll be like, which question is this one? Please go and start from there.
Thank you, sir. Thank you,
that
sir.
last one didn't come out. Oh, so he's still waiting for us.
He is still waiting for you. Don't say it did not come out. Start from
Thank you,
there.
sir. Thank you,
Link
sir.
it with, you see, when you start from that, the last part of this first semester, it will very smooth for you to enter second semester.
Thank you, sir. Thank you very, thank you.
So you are welcome. So
thank you.
I wish you guys good luck. Then
Yeah,
you are writing on the 5. When it's we will still have it probably next. Should we make it next week?
Yes, sir.
So
Next weekend will be fine.
which topic do we need to retreat now to check?
Let us treat past questions. Past questions.
Okay,
No,
there, but if you
Solomon.
treat
God
past
bless
question, if
you,
you don't
Solomon.
read, people will just think that is what is coming out.
No.
But if you can get me 2022, 2021 past question, send it to me. And then we can discuss it together. But apart from that, if I can get 2021, 2022, it will help.